We are doing 88. I had to laugh. I noticed in the recycling bin I saw someone's 87. I thought, oh, smart move.
I'm going to keep it authentic.
Keep it authentic. Trevor's like, nope. Just don't pull out more than one page. That could be a problem.
Somebody's trying to sell later, so you have the full version. Yeah. I'm going to sell my calculus notes to next year's calculus class.
Not even like the homework,
just the notes.
they like it's in a different book.
Not next year, they won't be.
I'm not going to tell them.
It'd be the following year. Okay, separable differential equations is our topic today. So we are looking at ways, thoughts, how we can use our differential equations here. Oh, I didn't get those right now. Okay, so we got a few basic steps here, and then we'll work on them. Step 1, get all the y values and x values on opposite sides of the equation, including dy's and dx's. Okay, so maneuver everything to opposite sides of the equation. Step 2 is integrate each side of the equation, putting the c on the side with the x. So traditionally we tend to put y's on the left, x's on the right. And so when you integrate, you don't put a plus c on both sides, just one plus c to represent the whole problem, and we'll put it on the right. And then step 3, solve for y, if possible, leaving c in the problem. Okay, sometimes we have information and can find c, sometimes c just stays in the problem, just kind of depends. So as we look at a very basic example here in example 1, solve the following differential equation. dy dx equals 4 cosine x. So the first idea is to separate x's and y's. So if I'm going to separate x's and y's, what does this become? Yeah, multiply, since it's dy divided by dx, multiply the dx to the other side. So then it is dy equals 4 cosine x dx. Officially that 4 could be on either side, but I think I'd rather have it as a 4 than a 1/4 personally. And then once you have separated your x's and y's, we're going to integrate each side, because how do we get rid of a dy and a dx? We're going to integrate. What is the integral of dy? Y. In other words, what is the integral of 1? And it is y. Carry my equal sign down. The 4, you could go ahead and just carry that down if you want, because then what you're really asking yourself is, what is the integral of cosine x? No? Mm-hmm. Yeah, you're overcomplicating. Because what has a derivative of cosine x? Sine x. So we've integrated both sides, and then we're going to say plus c.
I still feel like sin x would make a good medication.
Oh, and step 3, I guess, is to solve for y, except that this one was already 1y, so there's not really anything we need to do there.
So if they would have put the 4th over, we would have had to do that step twice.
Right. Which is why I would definitely rather leave it. Okay. This is more what we're going to use in the next problem. I can't remember. Okay, so remember our exponential growth and decay formula. It's derived from doing this process. And in all honesty, it doesn't look like I've worked this out in the past. So just when we talk about exponential growth and decay, we often will use maybe y equals a to the x. No, b to the x. I'm trying to, oh my gosh. Sorry. if we're talking money.
Okay.
Okay, so just typical growth decay, like not, because when you talk principal, you're talking growth or
Isn't it
money.
A not E to the KT?
Yes.
Okay.
Yes, that is what we're looking at there. I'm just struggling to, and, okay, so based on what this lesson uses, I have written Q because they use Q in this lesson. Why they use Q in this example. Notice the DQ, right? So, I say, did anyone else? Daryl caught it. Notice the DQ. I didn't even. Okay. But yeah, so if we use the same steps here, as I said, I'm not going to take the time to do it, but Q equals A times E to the KT. So that A, E to the KT, where A is your initial amount, right? Okay, and then K is some constant, is our exponential growth and decay. Okay, and that's the type setup we're going to use on this next example. I think instead of Q, for some reason I have N in my notes. I'm trying to remember where, maybe just N is what the book uses. But, okay, so that growth decay formula sounds familiar. It sounds like I'm butchering it up, but, oof. Okay, so let's look at this right here. The rate at which a certain bacteria colony is growing is proportional to the number of bacteria present at that time. At time t equals 0, there were 1,000 bacteria. At time t equal 1, there were 1,050 bacteria. Write an equation that describes the number of bacteria present as a function of time and determine the size of the bacteria colony at t equals 4. Now, officially, whatever variable you choose to use is kind of up to you. However, the book uses N for bacteria. Okay? And so, if we take this form from above, the dq over dt equals kq, well, in this example, it would be dn over dt equals k times n. Okay, that's the idea that the change in the bacteria is going to be some constant times that. Now, what is it? What's the formula that we're actually going to use? N equals A E K T. Except I'm going to write it N of T Okay, so just on that one, just, knowing the forms from above, mimicking the forms from above. Again, I'm picking N because that's what the book uses for bacteria. I said N of T just so I have a way to note certain times. Because what are we given?
0.
At 0, there were 1,000 bacteria. So one way to say that is N of 0 equals 1,000, right? Because at time 0, there are 1,000 bacteria. Now, in this particular equation, where is that going to go in? That's your initial value, isn't it? So you can, if you prefer, you could also just say initial value A is 1,000. And then we also know what? Yeah, at time 1, there's 1,050 bacteria. So N of 1 is 1,050. And then what are they asking us to find? Yeah, our goal here is to find N of 4. Okay, so if we are using the equation form, N of T equals A e to the KT, we already know A, yes? So we already know N of T is 1,000 times e to the KT. Before this is a working equation, what do we have to do? We have to find K, yes? What information can I put in to help me find K?
Time is 1, N of 1 is 250, and K is 1.
Okay, so we can fill in the time 1 equals 1050. So N of T, 1050 equals 1000 e to the 1K. I was just writing K times 1, but 1K, or it's all going to just be K, right? Okay, what do we do first? Okay, divide by 1,000. What is 1,050 divided by 1,000? Move that decimal 3 places left. 1.05 equals e to the K. I just taught solving this in Algebra 2 yesterday. Yeah. I take the natural log of both sides. I had a student yesterday said, well, I was just doing the opposite of that left, right, middle, which also works if you can, undo that. I just simply teach the natural log of 1.05. It's the natural log of e to the K. But what do we know? Yeah, natural log of e to the K is just going to end up being K. So we know that K is natural log of 1.05, which is some lovely decimal, right?
You have me really confused because I always just, whenever I take the natural log, I just always cancel out the natural log and since it's the same thing.
So you just skip over that and go straight to K.
Yes, you had me confused.
Yeah.
So I did something else.
No, and that's, Nathan made the comment of moving the K out front. We know natural log of E is 1. There is, and this is what I generally think is, it's base E, that's E to the K, so since those match, it's just K, which, again, several different ways to think about this. Okay, using the fact that K is the natural log of 1.05, can we rewrite our equation? So, our equation, N of T is 1,000 e to the natural log of 1.05 times t. Officially, you can't see it, I did put the natural log of 1.05 in parentheses because that t is not in the natural log. So that was one thing, right? Write an equation. We wrote an equation. And what else do we need to do? Yeah. Plug in 4. So 1,000 e to the natural log 1.05 times 4. Calculator problem?
Yeah.
Did you do it?
This is some easy mental math, isn't it?
Oh yeah, e to the natural log of 1.05. It's at least like 1, maybe. I don't know. Is it?
I don't think so.
It's a number.
There is a 1 in there.
It is more.
There's 2 ones in there. I have 1,215.50625. So if we are 1215.5063, if we go for 4 decimal places, or 506 if you go for 3 decimal places. This is writing an equation. And the size of the bacteria colony at T equals 4. It must be the way it's asked in the book, because I have just gone to a whole number then. Except because it's talking about bacteria, for my whole number I just left it where it's at. I did not round up. Okay, so it's that fine line of, do you round up and say, okay, approximately 1,216 bacteria, or technically there's not that 1,216th bacteria there. There's only 1,215 whole bacteria. Just depends on the situation. So I have 1,215 bacteria.
Last night's homework had a problem similar to this.
And I say, I'm sure it probably did because they usually like to lead in. Although, that was a couple of lessons before, so we missed a couple of lead-in problems. If you think, by not doing 86, 87 homework, we missed a couple of lead-in problems there. But, yep.
Sometimes they'll leave you in for like 3 nights in a row. I feel like.
Well, so you got the initial lead-in then last night. Okay, questions on that one? Okay, let's try the next. Example 3. The slope of a certain curve is twice the value of the x-coordinate everywhere. Find the equation of the curve given that it passes through the point 1, 2. Nice and broad. Nice and vague. Thoughts on where to begin?
I want to.
Nah, I'm going to end at 1, 2.
So remember that it would be 2x.
And what do we use? So slope, we know, is derivative. What do we use to signify slope? F prime. What other options do we have? So the slope, dy dx, of a certain curve is in math is equals twice the value of the x-coordinate everywhere means 2x. So how do I solve?
Multiply both sides by dx.
Okay, separate your x's and y's. So if we multiply the dx over, I'm going to have dy equals 2x dx. Then what? Okay, take the integral. The integral of dy is y. Integral of 2x. So y equals x squared plus c. Now, that is what you would call your generic solution. I forget if that was earlier this year or this one. But that's your generic, right? It's just, broad. It covers the whole thing. Specifically, though, what's it asked us for? The equation of the curve that passes through the point. 1, 2. What are your thoughts there? Yeah, plug 1 and 2 in. So 2 equals 1 squared plus c. So we know that c is 1, and my equation is y equals x squared plus 1. You like that kind of math?
The stuff we've done for years. The stuff we could do in 6th grade. I guess mine is
Probably 7. I don't think we learned slope interception.
The stuff that you can still mess up, though.
You still can mess it up.
The arithmetic.
I'm less likely to mess this up.
Okay.
There's not a paragraph of writing for each question.
It takes 6 lines to do it for the stations.
Okay. You ready? I can wait if you want to be a smart aleck there.
Minus x dx. I think that's the wrong problem.
Here we go.
I got through.
Sorry. It was really zoomed in, so then I was trying to find the right problem and I messed it up. Okay. Find the General solution to the differential equation x dx plus y dy equals 0. So what do I do first?
Isolate the variable.
Okay. Separate those variables. What would be easiest to do here? Subtract the x dx, keep the y dy where it is. So then I have y dy equals negative x dx. It made that easy on us. So now that I have my y's and x's separated, I can integrate. What's the integral of 1y? 1/2 y squared. What's the integral of negative x? Negative 1/2 x squared plus c. Now, I don't know about you, but that form's not very pretty. Okay, so we could look at the idea of, well, okay, but interesting enough, C is a little bit different. Okay, C is a little bit different in that, okay, Daryl's talking about the 2's are going to cancel. And how would we get those 2's to cancel? We would multiply by 2, right? Even though there's that C there, we don't have a definite value for that C right now. And so you don't necessarily have to, that C just kind of stays a C. You don't necessarily have to multiply it by 2 or do whatever else you do to it. It just kind of carries through as a C. Because we don't have a value, you know, we don't have a definite value for it or anything yet. Does that make sense? There you go. So if we multiply this by 2, I'm now going to have okay, y squared equals negative x squared plus c. There's two different options of how we could go here. What's one option? Okay, if we are strictly saying we're going to solve for y, take the square root of both sides, and then officially we would say y is equal to plus or minus the square root of negative x squared plus some number, right? Now, and this is one of those things, you know, the comment up front was solve for y if possible, or, you know, maybe I shouldn't say if possible here, but if it's makes sense to. If we do something different here, do you recognize in a certain equation? If we add the x squared over, do you see the circle? Because if we take minus x squared and add it over, this is x squared plus y squared equals c. And that c is going to represent the radius squared. Okay, now, this is one of those things, you know, there's not one specific right answer. There could be multiple different right answers. Because if you go and solve for y, that doesn't necessarily make it wrong. But if you see an equation that makes sense, then use that equation. Okay? Okay, one more.
Is the wording general solution have something to do with why you can use that answer instead?
Say what now?
How it says general solution, is that why you can use the standard form for a circle instead of
Probably, yeah.
Y?
Yeah. Okay. Example 5. Given the differential equation y prime equals 4x squared y squared, find the, this time we want the particular solution y that passes through the point 1, negative 1. Meaning, we're not going to stop with a plus c in the problem. So, okay, what do you know about y prime? Okay, another way to write that is dy over dx equals 4x squared y squared. what's your starting point here besides that? Okay. Multiply the dx to get all the x's to the right. And divide by y squared. Sorry, this one's not going to be quite as pretty. So if we divide, so then we have dy divided by y squared and equals 4x squared dx. So multiply the dx to the right, divide the y squared to the left. Now, what do you know about dy over y squared? Okay, so this is y to the negative second, dy equals 4x squared dx. And now you're in a better form to what? Integrate. What is the integral of y to the negative second?
-1 over y.
Okay, yep. Not the form I was going to do right off the bat, but yes. If you add 1 to the power, it becomes y to the negative 1, divided by the new power, makes it negative y to the negative 1. But yes, I agree, the next step I would say negative 1 over y. I was just going to take 2 steps to get there. What's the integral of 4x squared? Okay. Add 1 to the power, divide by a new power, so 4/3 x cubed and plus c. So now, if I take that negative y to the negative first, it's negative 1 over y. Still, 4/3 x cubed plus c. Thoughts on how we can do this? I would not yet, just because negative 1 over y is not a good way to have this equal to. Now, could you? I don't know, it's kind of ugly right now, so I would save that more for getting y by itself. How do we get rid of those fractions? Or not even reciprocals, but multiply by the denominators. I have a denominator of y. I have a denominator of 3. So I could multiply by 3y. It's possible. 3y times negative 1 over y. It's going to become negative 3. Sorry. On the right, we multiply 3y by the 4/3 x cubed. The 3's will cancel, right? Which is, getting the whole purpose there. And then it's going to be y times that 4/3 x cubed. And we could really say y times that 4/3 x cubed plus c, because we're not going to say y times c. Again, the c is just going to kind of keep hanging around. So I'm just going to write this as y times 4x cubed plus c. I about put the 4/3 right back in there. What does y look like if I solve for y here? Okay. Negative 3 over 4x cubed plus c. What do we have at this point? An equation. Not the particular equation yet. This is the general solution or general equation. we specifically need to find the particular solution. How do I find the particular solution? Yeah, now we're using the 1, -1. So y equals, so -1 equals -3 over 4 times 1 cubed plus c. -1 equals -3 over 4 plus c. To get 4 plus c out of the denominator, I would multiply by 4 plus c. And now that we're working with values, why did I write? Oh my gosh, I just wrote -1 equals. Now that we're working with values, I am actually going to multiply that -c, or the c by the -1. So -1 times 4 plus c, -4 minus c equals -3. To solve for c, add 4, so -c is equal to 1, divide by negative, and c is -1. Put that in your solution, and we're now at y equals -3 over 4x cubed minus 1. And this, of course, is your particular solution. Okay. Besides 2 needing change because it was from less than 74, 3, 4, and 9 are all from 78. So they're going to 17, 18, 19. I said 78. I meant 87. From 87. Because they are all from the lesson we skipped yesterday.